স্যার আমাদের সিটি 5 এর টপিক কি থাকবে?
Our circuit.
ওকে।
Okay. So we have a snubber circuit. Actually, why do we use snubber? Snubber means snub something. Snub means suppress or eliminate. Okay, suppress or eliminate. Why do we think those things? Because whenever we use a power electronic circuit, we have some switch in the network or in the system. Sorry. Mm, we have a fan regulator in our house. Okay. Oops, sorry. The negative side of this. During 80s or in the mid 90s, uh, actually it was evolved in 90s, like 1990s or something like this. During that period, just after the evolution of power systems, we have inductive load. This type of inductor actually was the fan regulator. Have you seen it? Do you have seen this type of regulator in your house? Maybe in your father's house. Okay. So actually these are the previous or primitive fan regulators. When we apply a 220 volt here AC, then there is a drop. So here the drop is minimum, and here the drop is a little bit or mid, or here the drop is maximum. So the fan always gets like 200 volts, sorry, 220 volts, 200 volts, or even 150 volts. Okay. So there is a constant drop in here, like 0, then 20 volt, then 70 volts. Using this regulator, we can control the speed of the fan. Okay. It was a regular speed regulator during like 60s, 70s, or even mid 90s. Okay. After mid 90s, we have developed electronic regulator. Why? In an electronic regulator, we can set the any output voltage, like we can set it like 215, we can set it like 210, or even any value like 208. We don't, whatever we need, and depending on that voltage, the speed actually regulates. But here it was a little bit difficult. There were only 5 steps. Okay, in that 0 to 0, 1, 2, 3, 4, 5, or some regulators are more primitive, like 3 or 4 steps. Okay. And another thing was that there is a constant loss whenever we regulate the speed. There was a constant loss inside this inductor, and this inductor is actually a inductive load, and the fan is also an inductive load. So the total AC power becomes a lagging power in here. If it is a lagging power, then if all the office fans are used in using an inductor, then it's a huge lagging power. Can you assume if a big office, like hundreds of ceiling fans with lagging power factor, what will happen? It will be a very large lagging load, and we do not want this type of lagging load in our system. Okay. So considering these two things, like the power quality and the speed regulation, we have developed power electronic circuit. Using a power electronic circuit, we can make it in this form. Here we usually use a triac. Can you see my figure? It is not good, but
Yes, sir.
a little bit. Okay. Here we usually use a triac. So when you can find this type of regulator circuit in the internet, it's very common. So I'm not worried about the circuit. I'm thinking about the output voltage. So whenever we use a triac, current can flow through this direction or in this direction, bidirectional. So we can use it. Okay. What will be the output voltage? So if we consider the output voltage in here, the what it will see. We are giving an input voltage of sorry, okay, this is the input voltage, and whenever we use a triac, we can find an output voltage like this. Okay. uh, the output voltage will be very similar. So this is the output voltage. We can make it even smaller or even larger, the output voltage. So if we calculate the RMS value, there will be no DC value, so only the AC value will be here. So if we want to calculate the RMS value, the equation of RMS value will come in this format. One by pi. Okay, so we'll have to start from alpha to pi. Okay, and then Vm sin theta whole square d theta, and this alpha is the dominant factor to define the RMS value. So this is not my point. Whenever you have to study this output wave shape, you can see that there is a sudden change in voltage. Can you see it? And there is a sudden, if there is a sudden change in voltage, there might be a change in current also. So if there is a voltage and current rapid change, so we need some protection to save the switch from any kind of rapid change, because this rapid change will create a surge in the circuit. It might be voltage surge or it might be a current surge. Is it clear? This is a simple, one of the most simple circuit or simple consideration in a snubber circuit. Okay, because here we are doing only 50 hertz. The change is only in with 50 hertz. But whenever we use a circuit with 5 kilohertz or even 20 kilohertz, 30 kilohertz, then there will be a huge change. So we need a snubber circuit to save a circuit from DVDT protection. We need a snubber circuit or a DIDT. Over current and for over voltage. Up to this point, we usually study in the undergrad level. And whenever we want to go for in an advanced stage, if we want to make a industrial subject or something like this, then we need to know about the current trajectory. Do you know trajectory? Do you know trajectory? Can you hear me?
Yes, sir.
What is the meaning of trajectory?
Well, if I throw something, the direction of the object is going to fly is the trajectory.
If it doesn't fly?
As in the path it's going to cover.
Yes. If you just go from one place to another, then that is your trajectory.
Yes, sir.
You might use a short path, you might use a long path. Okay, that is actually trajectory. Okay, do you have any question regarding this trajectory? In our Bengali term, it was just only Sanchar path, and in the English, it is a path followed by a like some kind of uh, equation or path or something like moving under some action. Okay. So now we'll study these 4 points: DVDT protection, how we can do it; DIDT protection, over voltage protection, over current protection. Okay, 4. So I want to give an idea about a DC motor. Okay. Could you please give me some points regarding the DC motor? What should be the voltage, or what should I select the how much should I select the voltage and current? Do you have any idea? Are you listening?
Yes, sir.
So do you have any idea?
No,
100 volts, 120 volt.
You don't have any idea regarding 120 volts. Okay.
100 volts, sir.
124.
Sorry.
So what is the current?
5 ampere, 6 ampere.
120 volts. Okay. So 5 is good. Is it okay to select it as a the BJT as a switch?
Yes, sir.
Okay. So the source is 120 volt and the motor is 120 volts. So whenever we switch on the we want to switch on the or run the motor, we need to switch on the BJT. Okay. So if we want to uh, use the motor in a half rated or full or semi half or something like this, like nearly full, then we need to control the duty cycle. Okay, we need to switch on and off this motor. So using this type of signal in here, we can control the speed of the motor and as well as torque. Do you agree? We have already studied this type of technology. So whenever we just change the voltage, what will happen? Whenever we just give an input current in here in this pattern, the switch will on and off. This switch will on and off. Do you agree? So what is the voltage? Change of voltage in here. What should the value of dV? When the switch is on, the output voltage, the voltage across the switch is 0. Is it under? Do you understand?
Yes, sir.
Asif bin Nizam. Do you understand?
Okay.
So when the switch is off, what is the voltage across the switch? Asif bin Nizam. Barjana Mama, could you please tell me when the switch is off, what will be the voltage across the switch?
Sir, 120 volts.
120 volts. Good. It's 120 volts. So what will be the change in voltage? Asadujaman, could you please tell me what is the change of the voltage? So what will be the change of the voltage?
Sir, 120 volt.
Good. So we can consider dV as 120 volt. Okay. So we can consider del V equals to 120 volt. So up to this point, do you have any question? So next, if there is no question, we can move forward. So what is the rate of change? This is not the, this is only the change. And what is the rate of change? Rate of change means in each second, how many times you are making 0 to 120 and 120 to 0. Okay, so it will depend on the input frequency of the switch. Okay, so if you make it 100 hertz, then it means that you will make 100 times the switch will be on and 100 times it will be off. It will become off. So on and off time will be like 100. So if we consider del V, if we want to make the rate of change, then this is if you want to make del V by del T. So del T means 100 times you are changing. So frequency, if frequency is 100, then del T is equal to 0.01. Do you agree? F equals to 100. So del T equals to 0.01 and del V equals to 120. So what is its value?
Sir, 12,000.
Good. It's 12,000. So if it is 12,000, I think it is very little bit high. Rate of changes del V by del T is not so low. Whenever you see that, okay, it's 120 volt, what will be the harm? But if you think that there is a change in del V by del T, then it's high. So what will happen? Why do we need a protection? Okay, now I want to give you another thing. Here I equals to 5 ampere. Do you agree?
Yes, sir.
It was actually your choice. তোমাদের থেকে একজন এটা বলেছিল. One of you have I have suggested to use this value. Okay, it's not the big deal. It's a 5 ampere is a nominal value, not so high, not so small. So if you take it 5, so the motor will also draw current of 5 ampere and it will just go to 0. So if you want to make it in a whatever you can see, we have switch on this motor and then switch off here. Okay, and switch off up to here. Okay, what will happen? You can see that whenever the current is rising, there is a sorry, I need to make it. There is a plus, there is a minus in here. Current is rising. Okay, the slope is positive slope. And whenever you have switch off that current, switch off the switch, and the current will not flow and it will just decay. So it will in here, in this direction. So this part will act, you can find that this part will act as a, this part will act as a boost converter. Can you imagine that it will actually boost up the voltage? If you consider a boost converter, can you recall that we have an inductor in here, okay, and we have a switch in here, and we have a diode in here. Can you recall this circuit? So whenever we switch, we close the switch, there is a current rise in here, and whenever we just switch off, the voltage is here is much higher, plus LDI dt. Can you recall this equation? Rakibul Islam?
Sir,
Can you recall this equation, the boost converter? You can't recall this equation or this diagram?
sir, ভুলে গেছি স্যার।
Exactly. So I'll just give you that point that it is actually a lack of learning. বুঝতে পেরেছো? তুমি কিন্তু তোমার নিজের ইয়াতে আটকে আছো যে তোমার আসলে লার্নিংটা হয়নি। তুমি হয়তো কিছু মার্কস পাচ্ছ, অ্যাসেসমেন্টে কিছু আসতেছে তোমার, হ্যাঁ, কিন্তু তোমার নিজের কিন্তু আসলে লার্নিং হয়নি। এই যে এই সার্কিটটা যে বুস্ট কনভার্ট হিসেবে কাজ করবে, এটা কি আমাকে আমার ইউনিভার্সিটিতে পড়াই দিয়েছে? এটি হচ্ছে লার্নিং, এবং এটি হচ্ছে লাইফ লং লার্নিং। বুঝতে পেরেছো? লার্নিং শুধু কিছু না যে কিছু অঙ্ক করে আসলাম, অঙ্কটা জমা দিলাম, স্যার মার্কস দিয়ে দিল, বাসে চলে আসলাম মিষ্টি হাতে নিয়ে। You have to ask yourself, by yourself, whether you have done it properly or not, whether you can solve any other problems relating this one, that is not. বুঝতে পেরেছো? আমাদের দেশে এটা হচ্ছে বিগ প্রবলেম। সব অ্যাডহক বেসিসে সবাই যে যার কাজ করে যায়। বুঝতে পেরেছো? যে কারণে কোনো জিনিসই বাংলাদেশে সাস্টেন করে না, এবং যখন যেটাতে আমরা সমস্যায় পড়ি তখন বুঝি এই লোকটা ভালো করে কাজ করতেছে না, কিন্তু নিজে কি কোশ্চেন করে দেখি যে এম আই ডুইং দ্য রাইট থিং অর নট। হ্যাঁ, কেউ একজন রাইট থিং করতে গেলে তার অনেকগুলা হিন্ডারেন্স চলে আসে, আই ডু এগ্রি, কিন্তু পড়াশোনাটা অ্যাবসলিউট তোমার। এটা যদি তুমি করতে যাও, ঠিক আছে, তোমার কাছ থেকে তোমার বই খাতা কেউ কেড়ে নিবে? ঠিক না? You have that internet facility, you that have that books, everything. If you want to buy, you can buy it. If you want to just lend it from someone, you can also.
স্যার এখন বলতে পারবো স্যার।
That's the learning. তবে একটা কথা বলি, অনেক আগে পড়েছিলাম আমরা, এগুলো ক্লাস 5-6 পড়ে আসছিলাম। গ্রন্থগত বিদ্যা পরহস্তে ধন, নহে বিদ্যা নয় ধন, হলে প্রয়োজন। কার উক্তি বলো তো? শ্রী রবীন্দ্রনাথ ঠাকুর। ওকে, দ্যাটস দ্য লার্নিং। আমি কিন্তু মেমোরাইজ করিনি, এটা হচ্ছে আত্মস্থ করা। মেমোরাইজ ডিফারেন্ট ইস্যু। মেমোরাইজ করে মানুষ টাকার হিসাব, ওটা মেমোরিতে। বুঝতে পেরেছো? আর আত্মস্থ করা ডিফারেন্ট ইস্যু। So hope so তোমরা আসলে you will not memorize those things, you will just make itself in your heart. Do you want to be an engineer, electrical engineer? So those things you have to keep in your heart, not in your memory. You want to be a good engineer or not? Absolutely, it's your decision. Okay, খেয়াল করে দেখো, আমি তোমাকে এটা কেন বললাম, আমার কি এটা আসলে বুস্ট কনভার্টার এই জিনিসটা এখানে না দিলেও হতো না, কিন্তু আমি তোমাকে আবার রিকল করার জন্য দিয়ে দিলাম। ইটস মাই স্টাইল। I think if I do it in this manner, student will be much more appreciated these points, that they can relate what is sir actually doing. So you have actually learned that here the voltage is actually additive, V in plus L didt. We did this equation earlier. So the switch will suffer a huge voltage compared to the Vin. So if I make the dt a smaller one, that is in the high frequency, if we make this f 1000, like 1k or 1000 hertz, then this will be the voltage will be 100,000. Do you agree? So if this is 100,000, that is pretty high. Okay, and you can also make the L and didt equation. So for that reason, there is a sudden change in voltage in here, okay, in this point. Can you see it? And this voltage is very high. So to snap this high spike voltage, okay, we need to use a snubber circuit. So what type of snubber circuit do we use in here? Here we actually, I'm drawing the circuit again, so you may also, so it will give you a better output. Okay, so Rakibul Islam, just start with us with some important information. Which element actually suppress this rate of change of voltage? One is capacitor and the other is inductor. Capacitor doesn't allow the rate of change in voltage, and inductor doesn't allow rate of change in current. Okay, so using the capacitor, we can suppress a voltage. Okay, and another thing, whenever we have used a freewheeling diode in here, like this point, this will allow the inductive current to flow in this direction. Okay, can you hear me?
Yes, sir.
Sometimes, don't you, why your voice is slow, so low? I'm not actually hurting you. Sorry.
No, স্যার, আমার মাইক্রোফোনটা একটু সরে গেছিল স্যার, এই জন্য স্যার।
Okay, okay. Actually, I'm just giving you some ideas, because whenever I studied in foreign countries, then I have found that most of the faculty members actually give a very positive input to the students. They discuss a lot of things outside the class topic actually. But in our regular Bangladesh study, we found that whenever we find any faculty member, he or she just enter into the class, they enters and make some things in the whiteboard or even the blackboard, and just go outside. But my school teachers are totally different. I found a lot of wonderful school teachers during my study, and I still recall their name. So we are giving a free-wheeling diode in here. Okay, Mohammad Tawhiduজ্জামান. What
Yes,
should
sir.
be the property of that diode? You have any idea? I'm just sharing my thinking with you. What should be the rate of this diode? You have any idea? We have the motor of 120 volts. Okay, and 5 ampere. Do you have any idea?
No, sir.
No. What should be the reverse voltage of this diode if you want to keep it safe? How much voltage will appear across this diode? Lamia Sharmin, Tamil Islam, Mushfiq Rahman, Shahid Amin, do you have any idea? Mirza Salem, Mashur Rahman, you don't have any idea?
Yes, sir.
Do you have any idea? What should be the voltage of this diode or rating? Voltage rating of this diode?
Mm, so 120 volt.
120 volts.
Yes, it's good. Excellent.
Yes, sir.
Excellent. So I need to clarify. So maybe you have understand, both of you have understand it properly, but I need to clarify for others. Here we have a 120 volt. Do you agree?
Yes, sir.
With compared to ground. Okay. Do you agree? So whenever
Yes,
we
sir.
switch on switch on this switch like this one, the voltage is actually, the ground is in here. So what is the reverse voltage now? Then the reverse voltage is actually 120. So the diode rating should be at least 120. The reverse breakdown voltage at least 120, and actually we choose it like 200 or 150 volts. Okay, 200 is good enough in our choice. Okay, now we'll go for the current rating. What is the current rating of this diode? Mohsina Tahsin or Mushira Khatun or Sadia Sharmin, Shajal Kumar Ghosh? Do you have any idea?
Sir, 5 to 10 ampere.
Good, at least 5 ampere is good. So the rating of this diode is 120 volt and 5 ampere at least. So usually we make if we want to make a very good stable circuit, then we choose a little bit higher. But higher rating always costs you a lot. So we have a trade-off. Okay, if we want to make a good circuit, then we can choose it like a 200 volts, 10 ampere. It's the diode rating. Okay. Now, what should be the protection of this diode? Because if we just use a simple diode in here, it will short path in here. Actually this, when the switch is off, this will become a short path. Okay, so we need to limit that current. Okay, so if we want to limit that current, so across this is 120 volts or more. It depends on the switching condition. It depends on the switching condition. So if this is LDI dt, the voltage will be VL. So this voltage, if we short path with a diode, if we short a VL with a diode, it will give us a short circuit current. So how we can mitigate this problem? We can add a resistance with a series path. Okay, now this resistance will confirm that the diode will not burn out. So we need to define first LDI dt. So for example, LDI dt is a 240 volts. Okay. We have 120 volt input and LDI dt is actually 240 volts. So if it is 240 volts and it is actually, it will happen in this form, a spike. You can see this type of spike in the circuit. Actually, this is the L dt spike. Okay. So if it is like 240 volt or something like this, we can think about a 240 volt short circuited, but the maximum current rating of the diode is 10 ampere. So we need to take at least 24 ohm resistance. So it will become 10 ampere. Okay, so if you choose, make a good choice of like 40 ampere, 40 ohm. If we take here 40 ohm, then it will become 6 ampere. Okay, it is your choice. So to protect the switch from LDIGT, you have to ensure a freewheeling path with a diode. So the diode will protect the switch from inductive surge. This change in the surge.
So it should be the power resistor, right?
It should be a.
So I think it should be a power resistor. I mean,
Positively, I am coming in that point. It's good. Thank you for your early deduction. It should be a power resistor. So we need a resistor in here, a resistance of, for example, 40 ohm. So what should be the watt rating or power rating of this resistance? You have to protect this resistance then. If you do not protect this one, it will burn out very soon. And if it is burn out, then the diode circuit will not work and then the switch will burn out. Okay. So what should be the rating? So if we consider the
So
power rating,
1500.
1500, actually we don't need this because here the motor is 120 volts and 5 ampere current is flowing, and maximum power or the surge power uh, energy will be very small. Energy will not that, the power will big. So if we consider that V square by R, here we have considered it as a 240 volts. Okay, so the power rating is, we can calculate 240 square divided by 40. So could you please do it for me? V square by R. So what should be the power rating?
So 1440.
1400.
1440.
Good. So it is 1440 watt resistance. Okay. So you have to first protect the switch, and then you have to protect that. You have to protect the switch. You need a diode, and whenever you use a diode, you need to protect it. Then you have to use a resistance, and the resistance has to be properly designed. Otherwise, it will not work properly. Okay. All these things requires a very good study. Otherwise, the system will not work. Rakibul Islam, is it okay?
Okay, sir.
Is it understandable?
Yes, sir.
It's a step-by-step study. Okay. So, so there is another change in the change in the voltage, rapid change. So I am going to draw that circuit again. Okay. You may just add, or if you can find it is better to draw, then you can draw it again. up to this point. Okay, we have already completed up to this point. So here is a change in the dVdt. Okay, if we suppress this dVdt, we usually use a capacitor. Okay, we will use a capacitor. Actually, what capacitors actually do? Does capacitor actually, whenever we just capacitor, if we draw the write the equation of capacitors, Vc equals to 1 by C integration of I dt. You are habituated with this equation. Okay, but I want to show it in a different manner. C dV dt equals to I. Okay, do you agree? Or we can write it in a CV equals to Q. We can write this equation in this manner and also in this manner. Okay, but you are habituated with this equation. Is it okay with you? So what will happen?
Yes, sir.
Whenever we switch off the capacitor, the voltage will rise. Switch off this BJT, the voltage will rise in this capacitor, and you will find this voltage is 120 volt. Okay, the switch is off. Okay, and the inductive, if there is an inductive drop, then this voltage will additive LDI dt. So the total voltage will become 120 volt plus LDI dt across this capacitor. Up to this point, do you agree? Is it okay with you? Do you understand? So the capacitor will charge with this voltage. Next, I'm just stripping out those things. And when we are going to switch on this BJT, if we switch on, the capacitor will discharge this circuit. Okay. So it is a short path for the capacitor. So what will happen? We are using a capacitor to protect it, protect the switch from dVdt. And whenever we switch on the BJT, the capacitor actually burns the switch. Okay. So is it acceptable?
No, sir.
No, sir.
So what should we do? We need to use a resistance to limit that current. Okay. So what should we do now? We are adding a resistance in here. Okay. So whenever we add a resistance in here, the short circuit current will be reduced. Do you agree?
Yes, sir.
Okay. So if the current is reduced, so it will also increase the charging time and discharging time. Do you agree with me? Because capacitor charging time, we have that equation, tau equals to RC. Can you recall this equation? Time constant?
Yes, sir.
Okay. So if we add a resistance in here, the time constant will be increased. So the capacity, so the charging time will be increased. So whenever we switch off the BJT, the charging time will also increase. Okay. And the discharging time will also be increased. So the current, because current actually I, we define I as a U divided by T. If this T is increased, then the I is actually decreased. Okay. Do you have any question up to this point? Shall we proceed? So we are adding a capacitor resistance with the capacitor to protect the switch for discharging current, from discharging current, but it will also reduce the charging current. Okay, so there will be a chance of DVDT failure in the switch. So every time we have a loop. So next, how we can mitigate this problem? We need to add, if we add a diode in this point, what will happen? Now the capacitor will charge through this short path. Do you accept? Do you agree or do you understand?
No,
Yes,
sir.
sir.
Please.
Moshiur Rahman, your voice is not so loud. You are accepting or not accepting. Maybe you have some sort of confusion or
Yes, sir. I have a confusion. How it will charge? Please, can you please explain again, sir?
how you do? How to? খেয়াল করে দেখো, যখন আমরা ক্যাপাসিটরটা শুধু অ্যাড করছি, হ্যাঁ, তখন সে চার্জ হচ্ছে খুব দ্রুত, ডিসচার্জ হচ্ছে খুব দ্রুত। এখন ডিসচার্জ যদি দ্রুত হয় তাহলে সুইচটা কিন্তু বার্ন করে যাবে। তাহলে সুইচটাকে আমরা প্রোটেক্ট করার জন্য কি করছি? একটা রেজিস্ট্যান্স অ্যাড করছি। ওকে, যখনই
Yes,
আমরা
sir.
ওই পথের মধ্যে রেজিস্ট্যান্সটা অ্যাড করছি তখন ক্যাপাসিটরটা চার্জ হচ্ছে স্লো, কারণ ডিসচার্জ আমরা স্লো করতে যাচ্ছিলাম, কিন্তু ওই একই টাইম সে চার্জ হবে স্লো। তাহলে স্লো যদি চার্জ হয় তাহলে আসলে সুইচের প্রোটেকশনের জন্য যে ক্যাপাসিটার দিলাম সেটা আমার 100% ইফেক্টিভ হলো না। ওকে, তো আমরা কি করলাম? তার সাথে প্যারালাল একটা ডায়োড দিয়ে দিলাম। খেয়াল করে দেখো, ইফ ইউ ইউজ ডায়োড ইন দিস ডিরেকশন, ইট ইজ ফরওয়ার্ড ইন হিয়ার, it is forward condition, but this diode is reverse in this direction, so current will not flow in this direction, so it will open, it will remain open. So when the discharging current will flow, it will remain open. Charging current, when it will charge the capacitor, it will become a short path, and when during the discharge period of the capacitor, it will remain as a open path.
Yes, sir. Now I understand.
It's an interesting phenomenon of diode. You are using a diode as a resistance, single one directional resistance.
Yes, sir.
Okay, diode is not only a rectifier. There are a lot of application of diode. You can use a diode as a gate. You can diode as an AND gate or gate. Do you know? We do have diode transistor logic, diode logic, and lot of logical things. Okay, so now we have another story of diode. Okay, now we need to protect this diode, because whenever it will charge, when the capacitor will charge through this diode, it will become a short path, so the diode may burn. So we need to protect this diode again. So how? We need to add a
Register.
resistance. Good. We need to add a small value of resistance in here. Okay. So if we add a resistance in here, you will find it as an active diode. Shahid Amin.
But again, sir, charging time will
Yes, sir.
less.
Yes. So charging time will be reduced. So what will be the new charging time? We have two. One is charging time, like we can make it very small. Like if we choose a very small r, then we can make it as a r into c, and this r actually r, and this is r. So we can, the discharging time is rc, and if we select, it's like, for example, 100 ohms, we can select it as a 20 ohms. 5 times or others. So, and the interesting thing that it will have the voltage spike. So if it is a voltage spike, then time is very small here, so the energy will be very small. Okay, for small time of energy it is okay, but whenever we switch on the BJT, it will on for a bit long time compared to this spike time. So there will be a discharging time will be more than enough to discharge the capacitor. Okay. So do you have any question up to this point? So this is the dVdt production of the switch, and for dIdt production we usually use a simple inductor in here. What is the production of overcurrent? Do you know? Do you have any idea of overcurrent production?
স্যার রিলে টাইপের কিছু ইউজ
দূর
করা হয়
বাসা বাড়িতে ফিউজ ব্যবহার করো না?
Mr.
This is
Fuse.
not
Please. Yes, sir.
fuse. Okay, so I shall give you these points in my next class. Okay, maybe in the next class we will complete all those things on Sunday. So we don't have any class except Sunday. Is it okay with you? Okay, so if not, you have any class question? So you can start your exam from 10:05 and you have to start it exactly, and you will get 20 minutes and 5 minutes for upload time. Okay.
স্যার আমাদের সিটি ফাইভ কি এই স্নোভা সার্কিটের উপর থাকবে?
Exactly.
Oh.
I am uploading the question now.
স্যার কি আছেন স্যার? স্যার কোশ্চেন তো পাইনি স্যার।
আমরাও পাইনি।
স্যার তো কোশ্চেন আপলোডই মেবি করেনি, পাবো কিভাবে?
10টা 5-এ স্যার বলো না।
আচ্ছা আচ্ছা, ঠিক আছে।
সেটাই।
স্টুডেন্ট কি দেখতে পাচ্ছ? So I want to stop the recording now if you don't have any question.